This is a quick overview and hopefully good first run of a PenBot prototype, a real quick prototype just to see if this is going to work. So really the idea behind this was to understand these stepper motors. This is a 28 BYJ stepper motor, and these are really cheap. And they're used all over the place. There's good support with them for the software libraries. They have a stepper motor in them, of course, and also there's a gear reduction. So there's about a little over 2,000 steps per rotation. So they're high torque, they're cheap, good support. They aren't very fast, as you'll see. So we'll look at that, but easy to integrate. And they're paired with, first let me talk about, I'm driving directly the wheels on this bot. So I have just these cheap little pulleys basically, and I thought, oh man, this is going to fit perfect. No, this isn't. This hole, at least on mine, is not threaded, and this is not the same size. So all I did was I drilled these out and then used a rotary cutter to kind of just friction fit them on, and you'll see it's pretty wonky. And then the tire, if you will, that gives it does give it some traction is just an O-ring. That also came with some of these plastic parts that I had laying around. The stepper motors do oftentimes come with these ULN 2003 driver boards. These really just have a series of, I believe, 7 total Darlington pairs in them. So on the bot here, these are the 2 driver boards. So there's 2 of these mounted underneath on both sides. And then the 2003 driver boards that are there. There's 4 digital connections that I'm using that are come from the Arduino, as well as digital power. And then I've also put direct power over to the boards. You can put a little jumper there and directly drive the motors themselves because it takes more current. You don't want to drive them directly from the Arduino. From an Arduino perspective, I used an Arduino Mini Pro, which is the same SoC or same microcontroller as an Arduino Uno. It doesn't have the USB interface. You have to use a serial interface, and it doesn't have as much pinout or as much voltage regulation. So probably wouldn't use it again, but I had it laying around, so that's what we're going to do. And then otherwise, this is a power distribution for power. Again, I kind of just had available this USB power bank, so that's what I'm going to use for this. And that's pretty much all there is to it. The chassis is actually a repurposed iPhone box, and I've put a hole here that I tried to put right in between the wheels to be able to put a Sharpie pen in. So other than that, the Excel stepper library is kind of the key software component, and we'll give it a whirl and see if this actually does work. So hopefully I can just drop this Sharpie down in there, and it will come out there on the bottom, and turn on the power. And fingers crossed, this will actually draw something. So it's making a mark, that's good. So as you see it running, the Excel stepper library will control the speed. So the LEDs that are flashing there are the actual coils in the stepper. And you can see that now that it's going full speed, straight, it'll be fine. As it approaches the end, you'll see it flash, and you can see it kind of slow, and then it turned. Hopefully it's still making a mark. Who knew? I have it just set up to go straight 1 revolution, so it's the length of the or circumference of the wheels, and try to go back to the starting point and draw a square. All right. Alright, well, clearly I have some work to do on the pen side of things, but hopefully you can see that you at least could go draw a straight line and almost return to starting point.